Hi everyone, in this lesson we'll be graphing piecewise functions. So in the last lesson we evaluated piecewise functions, so you already know that a piecewise function is a function defined by at least two equations or pieces, each of which applies to a different part of the domain. So here's one already done for you. This is a piecewise function broken into three pieces. They have three different rules, so we're taking three different sections of three different graphs and putting them together. Okay? We're going to do the next one on the next page, but before we do that, we just wanted to review some of the inequality symbols and what type of circles and arrows go along with them when you do your graph. So if you need to pause the video and copy these down, you can do that. And when you're ready, we'll turn to the first example. The first one we're actually going to graph is a piecewise function broken into two different rules or two different equations. The first half is 2x plus 4. And we're going to graph that when x is less than -1. The second rule or equation is -x plus 3, and we're going to use that rule for the x values that are greater than or equal to -1. So let's use those open and closed circles that we reviewed on the last page. Here, since it's a less than sign, we're going to be using an open circle at the -1 and going in the negative direction. For this equation, the equal sign says we'll be using a closed circle at the -1 and then going in the positive direction. So when we create our tables, we're going to create two different function tables for the two different rules. Okay, so set up your two tables underneath. The first one is f of x equals 2x plus 4. So that's like a y equals 2x plus 4. Now this, x is less than -1, is telling us what x values to choose. So we want x values that are less than -1. Even though it's a less than sign, it's going to have an open circle. We still want to include that number on our table. So I'm going to end my table with -1, and then I want x values that are less than it. So maybe -2 and -3. We want to do at least 3 or 4 points. Maybe I'll also copy -4 because I have space. So I'm going to go to my y equals. Type in the function rule 2x plus 4, go to my table. So normally we tell you for a line to just pick, right, this is going to be a line, to just pick 3 points. But remember, we have to pick points that are less than -1. We always want the boundary point to be one of the points that we plot, so I'm going to copy -1, 2 onto my table, -2, 0, -3, -2, and -4, -4. So I'm going to graph that piece of my piecewise function, and then I'll worry about the other piece. Just remember, we wrote an open circle here, so I'm going to have an open circle at this point, and then an arrow when I get to the other end. Okay, so let's plot those 4 points. So I have -1, 2. Again, it's an open circle. -2, 0. -3, -2. -4, -4. These points would continue, so when I connect my points, I'm going to use an arrow and extend the line to the edge of the graph. I'm only putting the arrow on the one end because I have an open circle here at this end. So use your ruler, connect from the open circle all the way to the edge of the grid, and put an arrow. Okay, for our piecewise functions, we do not have to label. So I'm just going to move on to the other piece. The other piece, or the other rule, is y equals -x plus 3. This one, I'm choosing x values that are greater than or equal to -1. So you want to start with that endpoint, -1. Okay, let's put my equation into my y equals -x plus 3. Let's go to my table. And remember, I want values that are greater than 1. So I chose -1. Let's also do 0, 1, and 2. You can pick more points if you want, but I'll copy these. So -1, 4, 0, 3, 1, 2, and 2, 1. Remember when I graph that this is going to have a closed circle on this end and then an arrow on the other end. So I have -1, 4, closed circle. 0, 3, 1, 2, and 2, 1. Take your ruler. And because there's an arrow on this end, I can extend all the way to the edge of the graph and put my arrow. And there we go. So I have a piecewise function. It was broken into two different pieces. This piece represents this top half, and this piece represents the bottom half. So number 2 is pretty similar. Why don't you try number 2, pause the video, and then come back to check your graph. Okay, here is your answer for number 2. Okay, this is the table for the top half. We had a closed circle going this direction. And this bottom equation, my table is here, and we had an open circle going that direction. Okay, we are going to skip over number 3 and try number 5. Okay, number 5 is a little bit different, so I wanted to focus on one that's going to have two different endpoints instead of an endpoint and an arrow. So if you look at number 5, we're still broken into two different equations. The first equation is the absolute value of x. If you can remember what the absolute value graph looks like, it's that V shape. But this time, I have -3 is less than or equal to x is less than 1. So because I have two inequality symbols, that means I'm going to have two endpoints instead of an endpoint and an arrow, like you would for, say, this one, right? This one's like a closed circle going this way. This one has two symbols, so we have two endpoints. Let's see. If you have an equal sign, that would be a closed circle. And this one does not have an equal sign, so it'll be an open circle. So when I create my table for this one, I'm going to go from -3 to 1 with a closed circle here and an open circle here. The second equation is just y equals 4. And again, I have two inequality signs, which means I'm going to have two endpoints. So look at the symbols to decide what the endpoints are going to look like. This one has an equal sign, so I'll have a closed circle. This one also has an equal sign, so I'll have a closed circle, and I'm going to connect. So let me create my two tables. The first table is y equals the absolute value of x. And they're telling me to go from -3 to 1 when I copy my table. So let's put my equation in. Math, num, absolute value. And again, they're telling me to start at -3. So the first point I'm going to copy is -3, 3. And then -2, 2. -1, 1, 0, 0, and they're telling me to stop at 1, so the last point I'll copy is 1, 1, because I'm stopping at the x value of 1. Okay, when I graph that, remember I'll have a closed circle here and an open circle here, and I'm going to connect them. So let me graph that piece. -3, 3, with a closed circle. -2, 2, -1, 1, 0, 0, and then 1, 1, just be careful when you plot the point because it's going to be an open circle. Okay, so that's one piece. I'm going to connect the points. And remember that absolute value is a V shape, but we just have part of it, so it kind of looks like a little check mark. Okay, the next piece is y equals 4. So let's make a table for that half. They're telling me to go from x is 1 to x is 6. So when I put this into my y equals, go to my table, I'm copying from where x is 1 to where x is 6. So I have 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, and 6, 4. Okay. Let's take a look at my endpoints. Remember I wrote before that they're both going to be closed circles. So when I plot these two endpoints, they'll be closed circles, and we're just going to connect. So I have 1, 4, closed circle, 2, 4, 3, 4, 4, 4, 5, 4, and then just check that endpoint before you do the last point. It's a closed circle. There we go, and connect your points. And there we go. So this piecewise, still two different equations broken into two different pieces, but we have endpoints instead of arrows. So go ahead and try the other examples in the packet and let us know if you have any questions.